All right, so this is the banner you might have seen when joining the event, and what we're going to be what the event is called is Traceability and Observability in Multi-Step LLM Systems. So sometimes these kind of complex titles sound like something niche and so forth, but multi-step LLM systems are something like pretty common actually, because it started off as like the very advanced players would use it. Then there are some mechanisms that just made it easier, and I think. Uh, just a general realization that for some reasons this is just kind of a better overall practice. So we'll talk about the specific agenda, but I think Mark is one of the folks out there that definitely knows this area, or at least how to understand what's happening between the different steps. Maybe best in the world. We'll see. You can be the judges of this by the end of the event. Quick comment, I put this also in the Discord, but maybe before some of you join. So in LLMOps.Space, we do a lot of the communication on Discord. So we usually don't take questions or thoughts and so forth from the Zoom chat as we're discussing, and only on the Discord. So please join this. There's a link in the chat. I'll also send it again later on, but please join there and ask in general chat questions. I know we don't always use Discord on a day-to-day basis, but it's still easier when there's continuity to the discussion. A bit about the LLMOps.Space. So it's a global community. We can see here, just looking at the attendee list, you can see people from all around the world, and it focuses on content, discussions, events, and so forth that are all related to deploying LLMs into production. I think there are definitely communities that are larger. There are communities that have more frequent events. There is bigger and better in every field, but I think there are two things that are special about our community. One of them is that it focuses solely on LLMs. We don't try to mix like a lot of different fields together. So it's not even a general Gen AI kind of community, but only LLMs. And the other thing I think is pretty special is that we try to aim the events to be for mid-level and senior practitioners. I think Mark and many of the speakers before Mark can also say that we practice what we preach, and we really ask that the slides and the content is tailored for folks that aren't at the very beginning of their journey, and of course those that are at the very beginning of their journey, then it should be also useful for them, even if it might be more useful if they first tried a bit with their hands and then kind of came back to this. But so it's kind of built like a syllabus. So if you start from talk number 1 and work your way all the way up to this one, which I think is number 14, then it's then you should like know more than you did about LLMs, and it's kind of built like that. So a bit updates about the space. So Mistral AI, which I'm sure many of you know, raised a lot of money now at a $6 billion valuation. They're joining the club of companies that are at this ballpark of valuation. So it's not only OpenAI anymore that's at high valuations. It's not the same ballpark yet, but it's still very significant in the terms, definitely in the classic terms of startup valuations. Apple and OpenAI announced a partnership in over a very significant stage. I think to many it seems like a very significant partnership. We'll only know when we actually see the user experience. I personally have my own iPhone, and I'm not yet happy with the experience with Siri. So maybe me and folks like me we'll see some difference here, where I have heard rumors about some discussions and so forth about how much compute it's going to cost within the Azure servers. So let's wait and see if it's all handled well. We have a new LLM model that supposedly outperforms Llama 3. Again, as someone that comes from the space of LLM evaluation, this is what we do at Deep Checks, I'm always cynical about these things until I try them with my own hands, and I haven't yet. And then we have Kling AI, which is a Chinese tech, which was released by the tech giant, the Chinese tech giant. I'm not even going to try to pronounce it so I don't get it wrong. So they announced Kling AI, which is very similar. I joked with Mark that it's very similar to his last name, except Mark is an actual human. So it seems like it's groundbreaking text to video capability, but again, you should definitely watch the videos and so forth, but get to the point where you can try it yourself. So we just had on the Deep Checks hat, but definitely within part of the community, we had a joint event with Neo4j and Pinecone in San Francisco right before the Gen AI summit. So this is maybe a good time to say that in the meantime, we've only been doing or we've been focusing on virtual events, but for physical events, if you're interested, then you can definitely reach out and we can try to do something together. And something that isn't out yet, but just so you can kind of get a feel for it. So at least now, if you go to the website, LLMOps.Space, you'll feel it kind of feels like Notion. It's built on Notion, and then it's we're using an external service to make it act like a website. So it's going through a revision, and this is kind of what it's going to look like. So hope to release it publicly in a week or two. And the next DeepChecks event, not on my hat as CEO of DeepChecks. So we're having an event with NVIDIA. I'm going to send a link later about how to make a safety net for your LLM applications, and we're having it next week. So definitely sign up and ask any questions you have before, during, or after the event. For Christopher, that's been an amazing collaboration working with him, and Sheila on our side. And now a bit about the agenda for today. So Mark is going to give a quick introduction to observability fundamentals in LLM ops. He's going to talk a bit about why traces are important to track LLM applications, and talk about the difference from classic observability, and dive into one specific use case, which is obviously RAG, right? Like which other one use case would we choose? It's just the most common, and it has enough interesting angles to it. So a bit about Mark. Mark's co-founder, CEO at Langfuse. What I really like about the vibe is the open source aspect of it. So a lot of what you'll see, you can really recreate building on working with open source. They're at Langfuse, they're graduates of Y Combinator, and I think there's definitely the advantages of the European startup and the culture that we have that I got to see when kind of working with Mark towards this session, and it's a pleasure to have him here and really talk about a subject where he's definitely the subject matter expert. Myself, I'm a moderator here at LLMOps.Space, and where I spend most of my time as co-founder and CEO at DeepChecks, where we do continuous validation of LLMs and AI. It's a space that's kind of related to what Mark's building, but not the exact same thing. Not going to dive into like the different areas of focus here today, but it was definitely interesting enough where I think both Mark and I felt completely comfortable collaborating on this. So again, we're going to have many future interesting events. So feel free to reach out or to refer your colleagues. And Mark, you go. Over to you.
Cool. Thanks for the introduction, Philip. I'm trying. Okay. Yeah, thanks again for having me. Generally, my goal would be to share a bit of the learnings we have made, how to use like trace and observability in general to power LLMOps workflows, to really go from something that's kind of cool to something that's working at scale in production. I'll sometimes throughout the kind of conversation share screenshots from our open source tool, but I think the content is really generalizable, and you can take like whatever tool you want to use to really power this workflow. And there are like also a couple of other open source solutions out there that you can pick and choose from. And the insights are mostly from our own experience. We as a team building agentic applications while in YC, and then now from working with thousands of teams who build super interesting and complex systems who we've collaborated with over the last year. And I think the focus of the session would be on teams building applications with LLMs, so mostly like engineers, data scientists who are on the application layer and make creative use of LLMs, but not of kind of folks that are mostly concerned with like training new models and breaking the frontier on the model layer. So maybe let's start with a simple example, tying back to what you just mentioned of these systems becoming increasingly complex. So for example, I just like simplified something of one of our customers, for example, who built a customer support RAG chat that just does like when a user question comes in, does some kind of routing step, then extracts a query from this routing step. It's more like metadata extraction to, for example, like filter then the documents that are retrieved. Then for the rest, they rephrase the query, embed the query, then do retrieval on the metadata and the embedding of the rephrased query, summarize the docs that come out of the retrieval step because otherwise it's too much for the context and too slow, and then finally generate an answer based on the summarized docs, and then pass through a security check, which could be like NAML guardrails that you just mentioned. So generally, this is like how we kind of improve performance, latency, cost of these applications. But I mean, each step can be, in the end, the quality, cost, and latency bottleneck. And when looking at the system, you always need to have a look at it like holistically and individually. And I mean, many of these steps aren't even like LLM kind of systems or like steps. For example, the security check, you might just do like a regex match, or the extraction might be like just like pattern-based or algorithmic. So in the end, just like we'll have a look at the system end to end, no matter whether it uses LLMs. Yeah, and it needs usually like hundreds of iterations to get from like an exec or hackathon demo to something that really is reliable in production, where you feel confident shipping it in a huge organization. These were just examples of steps. There are like tons of others, like agent state, context retrieval, tool calls, memory management, chat history, security checks, what have you, like whatever you see like on Twitter on papers, to then see whether it kind of improves the application. We feel traces and spans as a concept like map the best way enough to track what's going on in these systems. So for all of you that are more on the like non-ops and more application layer side, super quick recap on these terminologies. So we start with spans, which are basically single observed steps of an application. They are nested, they have timings, capture input output. You can derive metrics from them, or they contain metrics like LM token counts or costs, and have error states. And then there are traces, which basically group these spans and might be like reference like an API call or a single agent response, and could contain then like metadata such as like a user ID, a tenant, or however you would then like to group basically your application. And on the right, just like a quick screenshot from Langfuse, where you see like this is a trace of like QA, which would be, for example, the Q&A retrieval application I just shown you, and then the different like nested spans with different error states and timings. Based on these traces, I mean, this was like a tree representation. Other ways to look at it is more like a timeline, which is kind of helpful if you want to look at latency, or then the metrics that I described that you can extract from this logic. Okay, this is for the kind of recap on observability. Now more towards like, how is this a part of the regular LLM ops workflow? These traces are a great way to capture raw data in development production, and then to decide later on what to actually do with it. That's like the most common workflow we see of, let's capture everything, trace everything out, and then both in production and in development, then after the fact decide, oh, I saw this one bug based on a like feature request or bug report by a user. Let's have a look whether this occurred over the last 3 months based on the traces we captured. To store evaluations, annotations, and user feedback directly on the raw traces. So have like one kind of data store to then store your experiments. To later on fine tune based on the evaluated production data, because if you might start like off on a bigger model for one of these steps along your application, it's really cool to then have it evaluated well, to know which kind of subset of production data might be cool to then fine tune a small open source model, and get to continuously build a data set that improves in development and that kind of monitors or mirrors what happens actually in production. Yeah,
so
again,
maybe just one comment about the building data sets to continually improve in development, but also in production. So I think what's really cool here is, I mean, right, a lot of times when you were working with classic machine learning, or those of you that maybe have heard about it but didn't deal with the classic machine learning, so you have a test set, right? But then sometimes it can be great in the test set, and then in production it's not amazing. So I think what's cool here is like almost by definition, you have to iterate with what's then was the test set, and now is the evaluation set, right? Like you'll be taking samples from production that are representing like the new distribution that you're encountering and bringing them back in. So maybe that should have been what was happening also in the classic MLOps, but in practice, I can say from knowing enough use cases, that's not what was usually happening. It was usually a constant kind of test set, and then maybe there was a validation set that would change a bit more. But I think the DNA here is being built mainly because it's a harder problem, where the evaluation set is something that kind of lives and breathes and kind of gets and nurtures a bit from production.
I think the biggest problem often is that the inputs, basically the user brings the input, and it can be anything, and they feel like it's magic, and they often can also bring their own context. Like, I don't know, I want to create like an automated pull request, and they bring their own repository, which might be like completely scrambled compared to the things you tested on before. Yeah, maybe this comes up again because the use.
So just 1 second. As you're going here, I'm going to launch the first survey. All right. So we'll have it run kind of while you go through the next slide or two. I'll just kind of say it here out loud. So what is the current development stage of your LLM applications? So it could be conceptualization and design, development and testing, production and deployment, or optimization and scaling. So it's always amazing for me to see. It's also amazing for me to see how there are more folks either in that the position and scaling or in the production and deployment phases, like than there used to be. So we'll let this kind of go alongside your presentation, and I'll stop to show the results at some point.
Cool, thanks. Maybe let's jump on the different use cases, because the one you mentioned around like identifying what's actually going on will come up later in like 30 seconds. So in development, usually it's really about like debugging step by step what's going on, especially when using frameworks, because when you're early building a new application or prototype, or like trying tons of different techniques on how to potentially solve a problem or on the macro level, and then having a look at what happens step by step and seeing where the bottleneck is really interesting. Also, like it's more about these dataset experimentations. I'll give a concrete example for datasets in like 10 minutes, and to document and share experiments, because otherwise if you just console log them and then like 1 hour later realize, oh, it kind of like you didn't increase in quality, to say it nicely, it's really difficult to then understand like what did I actually do 1 hour ago and why did it behave in a good way. So it's a lot about tracking what's going on, and then in production more about monitoring cost, latency, quality, to debug issues identified. I'll touch on how to identify issues, and to be the basis for your whole evaluation workflow, and maybe cluster user intents if you're unsure about what users are actually doing and where they might be like out of sample, basically, from what you developed for. Before touching on the like detailed example, often it's really interesting to contrast how LLM observability is usually different from traditional observability. And maybe I finish with the punchline first. Usually it's just like living side by side, because it's a really different workflow. The one is more concerned with like keeping a service up and understanding bottlenecks, and the other with like actually improving the application. Like if I'm an application developer, I wouldn't like look at Datadog to understand whether I should make the button bigger or something. But here it's like very much like this, that you need this as a core piece of your workflow. So what's similar is you want like fully async instrumentation. It shouldn't be in the critical path. You want like spans and traces as like a core abstraction. As said, it really maps well to these complex multi-step systems. Then you have metrics that are kind of derived or ingested. When LLM observability, many of them are like derived ex post from the traces. So if you run like eval runs, so you don't know them while ingesting basically the data. Exceptions are interesting. In usual observability, usually you know what's an exception at runtime often. It was like just like an HTTP 400, 500 or something. But here, like in LLM observability, often like the application returns text and it's very confident that it's text and Datadog is happy about it. But like after the fact, you realize it's kind of gibberish and not helpful. So like what's an exception is kind of blurry in this sense. Then the main use case, where in observability, usually it's a lot about alerts, metrics, aggregated performance breakdowns, to really understand how your application is doing in production. And in LLM observability, it's more about like debugging single traces, building data sets for testing, understanding patterns and use cases, to really understand how your application is used. I think the usage patterns are way more similar to like an amplitude or a mix panel, but for the LLM backend, than how many users would use observability tooling usually. And finally, this also reflects on the users, where it's not ops, but more machine learning engineers, software engineers, data scientists, and now also like many non-technical folks who, for example, develop on prompts or run like annotation workflows within these systems.
By the way, for the non-technical users, we at DeepSex, I learned this term and I really liked it, but that we call them coders and clickers. So there's the coders. There are many different users that can be part of the clickers, right? It doesn't, they can be a lot of times very smart, sometimes smarter, have a lot of domain expertise, but it's at least from the UI or UX expert, it helps us kind of understand who we're designing each flow for.
Yeah, we just started like building more for clickers then, I think, in recent weeks, because before we started out really like technical focusing on engineering teams only, and now realizing it's usually PMs running the workflow, data scientists who know like how to iterate well on data, engineers then building the thing because it's like in production from day one, and the like domain experts too, because they are the only ones who can really assess whether the output is any good. Yeah, and this also comes down in the focus section, last row here, where observability is really concerned with the holistic system. We always chat about like distributed traces and like having a look at your infrastructure end to end. Where observability is more concerned with, what's really critical for this application? Like what makes it slow, costly, or bad quality? And you really want to double down on these aspects and have like a rich detail of full inputs, full outputs, like very high cardinality, something that you probably wouldn't want to track in traditional observability, but which really is necessary to then drive this kind of data sciencey workflow that you need here. Yeah, and as said, it's not like a contrast, like you don't pick one of the two, but usually you do both. It's just like different people with different goals. That's it for the like general part. I would love to jump into like an example. Philip, do you want to have a look at the survey first, or shall we do that later?
Exactly. I was just gonna wait till you got to the next slide and then do it, but let's do it now if you right. So I'm gonna share the results here. So the question was, what is the current development stage of your LLM applications? As you can see, only 24%, which I think is amazing, are in conceptualization and design. Then we have development and testing, 39%, which I think is definitely always the funnest phase, but you know, a lot of times you go through it and then it's a failed project, right? So then we have production and deployment, which I see as like initial production, and then optimization and scaling. It's when you might want to be lowering costs, putting in monitoring and other tools, and potentially seeing how you catch the edge cases that aren't working well in production. So I love the distribution here. I think it's really interesting, and hope that means we'll also get better than average questions. So remember, questions in the Discord, and I'm there all the time. All right, feel free to continue.
Cool. Yeah, then I'll just pick like an example. We'll stick to RAG. Everything that I'm saying really generalizes to other applications as well. Just like an example, I think really helps. And I'll pick the one I built, I think like now almost a year ago. It's just like a simple RAG chatbot on top of our own technical documentation. But it's free. You can just head over to langfuse.com/demo, and you could even see like how the workflow works end to end if you wanted to. What will we look at? It's basically common issues of how to identify problems such as like missing docs for user questions, hallucinated responses, even though we had context or we had no context, like just the thing making things up, managing the history of a thread, because like many of these applications have some kind of state, and then you want to continuously add questions to it. Like these are like all like very common problems. And then if it's like user facing, optimizing latency is really interesting. Yeah, I'll touch on many workflows related to optimizing this application in a second. How it looks like as a trace. This will look similar across, I'd say, like LLMOps tools. Just an example from our project, where it's basically you have this kind of tree visualization where you can click through and then get like full inputs and outputs of what's going on with like timings and stuff. Yeah, first block that's usually interesting is like how to optimize latency. That's really similar, I'd say, to traditional observability, where it's not about like P95, P99, seeing like what kind of step is the most random or adds the most kind of like dissatisfaction to users, I'd say. Where we need to keep in mind that often the final or longest step in an application, if you optimize it well, is like some kind of streaming step where the phase while it's streaming doesn't matter that much for the experience, but it's more like time to first token across the whole application. And then it often is just interesting to have like a look at like a timeline of a trace. If you identified something that's an outlier, to then dig deeper on, oh, what step is actually adding such a long time here. For example, with this demo, I had like some struggles with our setup because we run, I think, on like a free Supabase instance or something. I don't know. I had like some kind of like latency issues when retrieving from PG Vector, and just seeing like browsing through a couple of traces where now the timing was like past 10 seconds. It's really then easy to see what's going on there. Very similar to traditional observability. What's not different is basically how to identify and reduce issues in production. So I quickly made this kind of like chart where you see like if you look at prod traces, you want to now like evaluate them based on like a mix of different strategies, because each of them varies in the quality and the frequency and the cost of the strategy. So usually you need to do all, and probably Philip can expand on a couple of these kind of strategies as that's kind of like your bread and butter, I guess. Like the challenge in prod is like you usually have no baseline. So identifying what's off is really difficult, and like user inputs deviate from what you plan for. So like even constructing good evals for prod is sometimes challenging. So what do most of our users do? It's like a combination of user feedback. So explicit, just asking for feedback. Implicit is really interesting. So whenever you can like construct some kind of like human in the loop kind of UI and then tie it back to the production trace, it's really cool. Manual annotation workflows, where you basically task users or like internal folks to label traces, or online evals. I'll touch on all four in a sec. But this is just like the high-level view on how to then spot issues in prod for this example of an application of a RAG system. And if we head next, like for the user feedback, it's really like just this kind of like thumbs up that we've seen across all these applications. So I don't know if this wasn't good. And what we can then do is basically link it back to the observability logic of a trace, where it's often then interesting, especially for domain experts or PMs, to just browse through like hundreds of negatively evaluated traces to get like a sense of what's like a common pattern, like which step really makes these traces bad, or pull them like via an API from some one of these systems to run their own analysis or classification on like the problems, and maybe just also to monitor to see over time how things change. And yeah, most of this feedback is like captured in the front, but as I said, it's even better if it's like not explicit, but if it's more like, oh, I generate like a suggestion. If I was like intercom, for example, I just generate a suggestion, and if the user just hits send without changing it, then it's like really nice feedback of the suggestion was good. This is usually the thing that works best across users. I feel like if you want to get a sense for quality in production, very different in testing, but in production, this works really well. Yeah, manual annotation, most folks I talk to dread it and don't want to get into manual annotation because they feel like it's super costly and slow. But then it seems like the only way to really investigate deeply negative user feedback, or to have like then like a baseline for automated evaluations to gain trust in automated evaluations, because each library or every package that you find for automated evaluating these traces, like you need like some kind of baseline. So it's interesting to annotate some data manually.
Right,
Yeah,
just one thing, like something that we're doing in our approach about the manual evaluation, which I think is really cool, is first of all, we're separating between user annotation and then like end user annotation, and then like the owners of the app, because we think that there's a huge difference. Users, it's great to get user feedback, but it's a lot more noisy, not consistent, and so forth. A lot of times there's just a few users that give most of it. So I think that's one really interesting thing. We like to look at that as like another feature, another property, and not to say, okay, this is gonna be part of like scoring the version. That's what I think one issue. Which, yeah, it's definitely what you put in the slide here. And then the other issue is that we like to play like back and forth between the automatic and the manual. So you do manual that helps train something that can help you do the annotated one, and also the opposite. It can help you measure how well your evaluation is working. So if you see ones that got both an automatic evaluation, but then also user thumbs up, thumbs down, or similar, then a lot of times you could kind of see the how accurate you were, which is it's kind of like binary classification, which is cool. Why binary? Also for you, I saw there's good and bad, so I like that a lot. Like in the beginning, we started working with a lot more complex kind of ranking methods, and we saw what we saw in many organizations, they tried it and then went back to the simple good bad. Mainly just because of discipline, like the people over time and consistency between people. Even if like mathematically it sounds better, then something didn't work there. So anyway, a few comments about the evaluation annotation, but I think it's really cool to see that we kind of arrived at similar conclusions.
Yeah, I think I can only add like a +1 of you need to correlate all, try all, like not stick to just one of them. And like also we played with like displaying basically ranges or like descriptions to help people like standardize on a scale. But then like standardizing on a scale is really hard if you have like a couple of folks annotating. So in the end, like just having big buttons makes it easier like for compliance, and then kind of making the outputs really usable and trustable. So yeah, that's for manual annotation. Just like heads up, most people dread it and don't want to get into it, but it makes a lot of sense usually as part of a workflow. And yeah, then like more online evaluations, for example, model-based, like it's kind of what everyone wants, but then like without a baseline, it's difficult. Just want to like quickly touch on it as it's like part of the workflow where I think for this kind of, if you look at the whole thing as like a tracing, as a trace from prod, then you have like a couple of different things that could go wrong. So now it's like interesting to devise some kind of like check for each of the steps to then get some kind of timeline for each of the steps that help you understand how are the different steps of your application doing, or maybe also like if you get like a list of problematic traces, to be faster at directly jumping into the step that might be an issue, because like some kind of automated eval already flagged that this could be like the problem within the trace. So I think there are different roles to this. And yeah, in prod, most folks sample as it's otherwise super complex. And yeah, I really like, for example, for RAG, as RAG was the example, this kind of screenshot from the Ragas, I think, documentation, around specific scores that you need to devise for the simple for the different steps. So maybe like how to assess a generation step is really different from how to assess a retrieval step, and also like how you assess it with a baseline and testing is really different from how to assess it without a baseline in prod. Yeah, good documentation to check out. I really like the docs. And yeah, now finally, I almost want to close things out with more like how to use them, trace that you retrieve from prod or from testing, and how to build this kind of continuous learning loop with data sets on top of these. Because I think for most folks coming from MLOps, it's really like simple to go from logs or some kind of prod data, even though Philip, you're mentioning that's not what's usually happening, but it could be happening or is more likely to happen. Going from traces data sets is, I think, even another step where we first of all have different levels of looking at it. Either you look at the like integration view of, for example, now user input and agent output, or like a unit level view of, or with like a user question and static, in this step, retrieval input, what's my output? So if you just want to iterate quickly on a certain step. And the overall goal of these workflows usually is to control for regressions in development or to benchmark different approaches really quickly. So like to, on the one hand, do some kind of like grid search on, for example, prompts or configurations. On the other hand, to be like implementing this in a CI to make sure that when someone devise like a new prompt in a playground, that they don't like screw over like a large scale of the user base that you're having. The bottlenecks here are really like to have a good data set that increasingly mirrors prod, and to have like a good eval function. So let's have a look at the workflow where let's start like how to come up with a data set that's actually useful, where most folks already have some kind of like manual data set, like a Google Doc or something that they usually use to interactively check the application, or some kind of like examples that they like to use. Then it's interesting to synthetically like generate questions and responses, or questions and then manually check for responses. And also from production, if you have a production app with traces, and then you are able to identify issues in prod, so like edge cases that you didn't plan for based on evals, annotations, user feedback, you can continuously add them to like a data set as well to get better at like mirroring actually what's happening in production. So, okay, now we talked about like how to arrive at a data set, which can be either at an integration level, a unit level, or whatever level that's helpful. What to do now with it is usually you make a change, either like lots of changes at the same time, or a single change that you want to test for. Then you run your whole application on or this kind of like function that you want to test for on the whole data set, come up with an output, and now you evaluate the output with or without a baseline. And these are already like the two, and now we already touched on the two most important parts: how to arrive at a really good data set that mirrors production, because otherwise the whole process is kind of useless. And now like what kind of evaluation functioning is helpful. While you could use like manual annotation for this workflow as well, I think it like heavily limits the size of the data set that you can use. So if you now want to run this on 200 to 500 or something examples in data set, you need really like an eval metric that's helpful. What many of our users do is that it's very different from how they evaluate in production, where they might want to use like model-based evaluation of, oh, is this helpful based on the question, like very open-ended and just like something that works on average, but not for a single response. Here, often it's more like rule-based checks often, but I think, Philip, you're probably way more experienced on this specific part. I just see a lot of like regex matches or like really rule-based stuff where you have a list of checks that you run on each of the outputs, and then basically the output of the data set is just like JSON of stuff where you can then configure which rules should be applied to the output. Okay, now we have basically you rerun the application. Sorry.
Wait, yeah, just one question we got from the audience. So anonymous attendee is asking, we're evaluating multiple tools, but have no idea in terms of annotation accuracy. So what are your thoughts on that, about having either inaccurate or maybe some sort of selection bias on the annotation accuracy?
So when you run basically an annotation program within your team, like what we see most people start with is basically brief people well and then hope for the best. Then the next stage is basically to have just multiple people annotate the same thing and then have a look at like correlations of these. And I think how annotation works well is like, it's like not an unknown problem. It's I think like teams such as like Label Studio, Labelbox, like it's like how labeling works well, I think is like really well figured out, and it translates 100% to these workflows as well. So it's about having good descriptions, having good scales, and then like just running kind of analysis ex post, like descriptively on like how did people annotate differently if you let it annotate a couple of times.
Right, I'll just add to this. I'll say I think that's the second order problem. The more important problem is choosing the evaluation set there, where I think there's a lot more unknown unknowns. If you choose like samples that don't really represent what you're going to need in production, that's a much bigger problem than having some inaccuracy in the annotations, because then you could be running like 20 experiments one after another, constantly getting better people, more expensive people, more voting, whatever. And then it's like, okay, we were optimizing for like a subset of what we actually need. So I think having a fairly small evaluation data set that actually works, but then having it be representative, it's an art, and it usually requires teamwork. Usually one person can't do it on their own. You might have many languages, then you have to think about if you're going to have a different evaluation set for different languages or one that's unified. I think there are a lot of different things to do, and it's an art. We deal with it all the time, definitely. So there's
You
another
think it's
question, but
interesting? I think it's interesting, like how you select basically, in our case, like a trace to be part of like the list of traces to annotate, where, I mean, while user feedback or some kind of like implicit human in the loop kind of signal might not be perfect, and actually like establishing like a baseline for quality, it's often like a good signal to then decide on, oh, if a user didn't use what we produced, it's maybe a thing we should have a look at. So like rule-based assignment of these traces often makes a lot of sense.
Right. So one other question you've got is if you have a benchmark experiment available for your tool. I'm not sure yet here if you dove enough into the tool, but first of all, the tool is open source, so you can see the link at the bottom. But anyway, if you have any thoughts about this, if there's a benchmark experiment for how people can compare the tool with something else.
Like benchmarking the application with our tool or benchmarking our tool against other tools?
I'm not sure exactly, but the question, anonymous attendee, if you can ask again this in a way that we can interpret easier, I think it'll be easier.
I can answer
Yeah.
both. Like for the one, we just have a cookbook you can run end to end, and for the other, Langfuse.com/y, we like outlined a bit of what we are building and why we are building it. And then like, I mean, we are open source. Like there's like nothing hidden about what we are building. There's like a public roadmap. Our docs are fully open. GitHub discussions about what people want us to build. And also you can just email me like mark@langfuse.com. Happy to help. Or like in the Discord after the conversation now.
All right, amazing. And for future questions, please just make sure everything's in the Discord. I took these because I thought they were important for the flow, but let's continue.
Cool. Yeah, thanks, Philip. I'm almost done. Where it's like now we have basically run our change on a data set and evaluated with or without a baseline. So we have an aggregate result, which you can now either use to flag a regression or to basically see, oh, this worked. So we should basically put it to prod. Happy to answer like more detailed questions on the tracing pieces now, but that's it for basically the prepared content. Thanks a lot. Feel free to like ping me anytime via email. Check out Langfuse, maybe stars on GitHub to get like updates over time. All the screenshot I showed were basically just to illustrate, I think, the basic concepts. There are many great products out there that are very similar or that doing like things in a slightly different way. So definitely try to figure out which one is the best for your use case. And yeah, happy to jump on for the Ask Me Anything on the Discords after the session.
All right. If there are any other questions, you can add them now. I see Paulo is still typing within the Discord. Mark, I'm adding your email here in the Zoom chat in case anyone wants to send you a mail. Reminding again, we have a deep checks event about LLM safety with NVIDIA next week. I also posted the link for that. And for any other questions, again, Mark and team are gonna do their best to answer any questions that come on the Discord also after. And I think that's enough for now. Maybe I have one question for you, Mark, on my side. What's when we're talking about a multi-step application, what's the most common use case for that you see? Like what's the most common reason why you have many different steps?
So like why people add a step? Yeah, that's interesting.
Yeah.
I'd mostly say like for like predictability or maintainability of an application, because usually folks go through, I don't know, if we start with a simple example of just like something that's a chat, usually you grow with like the prompt you're having to do everything within a single prompt. Then you realize, oh, this can be faster if you basically split it into multiple different smaller model invocations, or it can be better if you like, for example, use something like semantic router beforehand to route basically to specific states of the application to then have a specified or like specialized prompt. And once you are headed into this direction, you get used to, oh, I can like solve problems by decomposing them and having basically simple functions that do only simple things. They can then better observe and optimize. And once you start with this, you'll end up with like, I don't know, hundreds of prompts, hundreds of different abstractions and tools that your application uses. But I feel like semantic routing, state-based agents, and like just parallelizing some things are usually the way people get started with like going from a big prompt on a single LLM call to something that's more complex. And that's kind of like also the reason for it, and usually totally worth it.
All right, amazing. So we're getting quite a few more questions here, so we'll try to go over them quickly. So Paolo Tamagnini, I hope I got that right, is asking, if human-generated annotations are the way to go evaluate Llama apps, opposed to RAGAS or LLM the judge or so forth, then we can take a look at active learning and weak supervision. Is there any paper on how to optimize what to annotate using embedding scores?
Whether there's a paper to use embeddings to identify what to annotate. Did I understand the question
Yes.
correctly?
Yes.
I don't know whether there's like one specific paper I would point to. I'd say usually it's a mix of things, and usually each team knows like what represents best what's an issue in their application. So I would try to go from generic to specific for your own team and just try different things, see what mirrors basically a problem, and then use this kind of like identifier of this could be a problem to then label it for like being annotated afterwards.
All right, amazing. I will state in deep checks at the beginning, we wanted to do like clusters and then kind of just give you the clustering and then use that to help. There were all sorts of like cool cluster clouds that came out at some point. And then at some point we realized that it's actually easier when this is a bit more structured. So something that we kind of, something we realized is useful is when you present the topics, like you calculate topics, then you present them and you enable filtering by properties like toxicity and a lot of other things that you kind of did here, but we kind of created models for it. So if you filter by toxicity, relevance, grounded in context, whatever, then that can help you to understand both maybe what might be the most problematic, but also where you might want to annotate. So it's kind of semi manual, at least some of these things. Okay, another question for you from Giliu513. What is the plan to integrate with OTel? And
Interesting.
you got two thumbs up for that question.
Yeah, I love to follow the conversation. I feel like I think Nia is also on the call from Traceloop, and I know a couple of folks at Microsoft who are currently pushing hard on like semantic conventions in OTel for this. I mean, our data model is really close to OTel, and we currently wait basically for strong conventions to then build like basically collector. So because we think there are like two groups, the one that really wants this to be on OTel and the other one that doesn't care at all. And for most folks that don't worry about this too much because they see it as two distinct kind of workflows, for them, our product can just be better if we build it ourselves and, for example, integrate well with lots of different frameworks. But definitely want to build a collector to then for teams who really want their kind of like instrumentation and collection steps to be OTel compliant, to then just use Langfuse for the downstream workflow, but like pipe the same data into other systems as well. And we are currently building more like downstream, basically exported as well from Langfuse, where it's currently we just have like a partnership with Posttalk, but also plan to just like send webhooks or maybe produce then OTel events out of the data that we have in Langfuse to then pipe it, I don't know, to Datadog or something. So I think we think about OTel very holistically right now, but like monitor the space and try to time it when we build like a collector that's then stable without us needing to like make new conventions because we rather want to follow on this trend.
All right, amazing. So we have two more questions, but I'll take just one of them, and then the other you'll handle yourself. And two of them are from Guangya Liu. So Guangya, you already got one of your questions. So patience on this one, and you'll see it offline afterwards, hopefully from Mark. So Anya is asking, thanks for the talk about providing the great tool. Is there a way to quickly find best evaluation results for a set of dataset runs or experiments in Langfuse with different RAG configurations? How can you systematically optimize RAG applications based on evaluation results? Great question, I think.
Yeah, generally, like each, like I think there it kind of shows that we built for like engineers primarily, where just like everything that you create under the hood in Langfuse has like just like this metadata JSON object. So if you, for example, now iterate on, I don't know, your chunking strategy, your model, whether you add like a security step, you can just like add all of these as somehow like a run configuration. And if you then run evaluators on each of these dataset runs, you'll see how like things changed from run to run. And basically by looking at the diffs in the JSON configs, you would then see, oh, what did I actually change from this one to the other run? And that's how it's currently done. And maybe if you're especially excited about this use case, we're currently building more UI on top of these kind of workflows, because currently it's basically like all the basis is there, but I think we can do better in like the analytics within our platform. So that's like on our near-term roadmap to make this easier within the UI.
Amazing. I'm just launching the second and last survey. So actually, while people are answering, maybe we can take one more question. I was just reminded by Divya, my co-community manager, that I didn't launch the second survey. So Guanya Liu's second question is, can you share some persons for Langfuse? Like, who are the personas? Is it targeting data scientists or SRE for AI application, or both, or even more?
Usually it's like we always start bottom up with somehow the engineering team, the engineering leads, the PM. Usually like we started only with engineers who basically build these applications, which if they are like in the development stage is basically often like a mix of data scientists, ML engineers, and regular software developers, who then need some kind of platform to track the experiments. And then over time, often like PMs come in because they often had a lot of these kind of like annotation workflows. Or like higher ups or other departments. For example, sometimes we have like a finance billing department involved who is interested in like cost reporting on a by user level. If they, I don't know, want to limit or basically charge the users based on token counts. It's really like mixed. I think, Philip, you seem to be like more thoughtful about like building distinct UI for each of these kind of personas and clickers and I don't know, developers. For us, we're like developers first and now build more UI as we see like many different folks onboard onto the tool. We should probably ask like we asked like during onboarding like how have you heard about us? We should probably ask, who are you? That's a good question. I should have a better answer for this besides engineers.
All right, and then you'll get some philosophical answers. All right, so I'm sharing the results real quick for the second poll. Definitely less participants on the first one, partially because I did it at the last moment. But this is pretty cool. The number of LLM calls per interaction, which is either I'm just browsing, which kind of means, okay, maybe they're not building hands-on, and then it's either 1 or 2 or 3. We got 29% for one LLM call, 16% for 2 LLM calls, and 3 plus 45%, which may not be surprising given the title, but it's pretty advanced. So that has to do with the optimization and scaling thing that we saw earlier. All right, so I think currently we're going to conclude the session. Thank you everyone for joining. I'm reminding again, next week we have an event on the hat of deep checks, not of LLMOps with NVIDIA, about LLM safety. Would love those of you that want to join. Mark and also Mark's team that helped with the presentation. Thank you so much for this. For me, at least, it really filled in some missing parts that I didn't have very well in my mind. So the definitely how to position everything related to the traces and so forth. I think it's both the visualizations and the concepts I think are really important here. And how to reach Mark and Mark's team and to try their GitHub repo. And I'm sure also any feedback and things that are missing, they would also love to hear. So the whole space is pretty early. I think they're definitely one of the faster movers with everything related to this part. And it's a pleasure to host you here.
Thanks again, Philip, for the invite. This was fun.
Amazing. Bye.